P stands for?
Phosphorus.
Phosphorus. What's the charge, Bruce?
It needs to gain 3. So
Okay.
it'll be a negative
Negative how much?
3.
Negative 3. And that's the most common ion. Bruce, one other question. That is an ion. Is it an anion or is it a cation? You got a 50-50 chance.
Negative? No.
That's negative. Cats.
Cats all...
Cats are positive. You know, like, there are no dog ions, there are cat ions, and if there's cat ions, it's bound to be...
It's a bad analogy. I don't like cats.
You don't like that? Hey, for this semester, you got to pretend. Okay, so it's negative, so Russell, he should be calling it a what? Anion. Anion. Okay? Now, got magnesium. Right over there. Pedro, hit it.
Positive 2.
Positive 2. Anion or cation?
Cation.
Cation, because it's positive. When it became +2, what happened to it? How did it become +2?
To go away from right there from magnesium to become stable with that.
Yeah, isoelectronic with neon, it lost 2 to do that. Just like Bruce told us this one gained 3. What's it isoelectronic with when it's P minus 3? Bruce?
Argon.
Argon, exactly. It went up to being like argon. Okay, and then I have some Cl here. Antonio, hit it. What's its most common charge? There's where it is.
So the gain 1 says negative.
-1. Anion or cation?
And
Anion.
yeah.
Anion. Okay? All right, then we've got one more here to do. So, take a look at it. It's K, Andrew, hit it.
It'll be +1.
+1 and
Cation.
cation. Cation. Now, if you were going to name these, remember how this is kind of getting ahead in the chapter, but if it's a negative ion, it took a certain ending. Ide. So we can only name the negative ones this way. So if we go back to here, give me a name for that. Phosphide. Phosphide, and Al will make you type ion after that. Phosphide ion. Okay, this would then be what, Russell? Chloride ion to get full credit. Now, somebody asked me yesterday, how about those positive ones? They have no special ending. You just say magnesium ion, end of story. Potassium ion, end of story. No special ending right now. All right, that was review of that first part. That stuff was mentioned on the news so much over the weekend. Or on Thursday night and Saturday morning. Anybody hear about that compound?
Yeah.
What was it, Sarah?
Put it down to keep ice from
Put it down to keep ice from forming. Do you remember the name of it? Magnesium chloride. It was mentioned on the news a lot Thursday night and Saturday morning, or no, Thursday night, Friday morning. The reason for that, and you'll learn this if you take 1412, if you dissolve something in water, it will lower the freezing point temperature. So they were attempting to buy us some safety for a few degrees by putting out that salt. Now that is a salt. Salt's a broad category in chemistry. It's not just sodium chloride. In the north, and in your textbook, they always talk about they use calcium chloride to put out on the streets. But I heard for the first time here in Houston they were using magnesium chloride. Did not work real well. Either they didn't put enough or it got way too cold for it. But that was the thinking, is you make a solution with the rainwater and then the freezing point temperature is lower, so if it doesn't get past a certain temperature, then it's not going to freeze. But why do you suppose magnesium chloride or calcium chloride, either one would work? Okay, it's chloride, yeah. But what about magnesium and calcium? What connection do we have here? Magnesium and calcium. Meredith, tell us something. They're in the same family. They're related. So if magnesium chloride's going to work, probably calcium chloride's going to work too. And maybe this was cheaper than calcium chloride this time. Okay, now something else. Why is this correct formula? This is a hint of things coming. Okay, magnesium is +2, is what you guys told me. Okay, fluoride is -1. That's what you told me. Well, compounds are neutral, electrically neutral. So if this guy's plus 2, how many of these guys should it take to balance out charge? 2 of them. And so that's how we write it. And there's a down and dirty trick to do this. This almost always works. Now that's understood to be a 1. Double crossing down. So that's understood to be a 1, that's a 2, and then we clean it up and turn it into that. Formula writing. All right, now, let's get back. We were in this section, and we worked one problem together in that section where we talked about moles. And I said, if you've ever been confused about moles before, just think about it like a dozen. It's just a bigger number. Okay, Avogadro's number. You know, the number of atoms in a mole of some element. Let's hear his number. 6.02. Very good, very good. 6.02 times 10 to the 23rd, a number you need to know. And I said that doing this will haunt you throughout your chemical career. 1411, 1412, even some in organic. So, this is strictly for elements. This is section 5, just for elements. When we hit section 6, we're going to talk about for compounds. So, I've got grams, and I would like to get to moles. Nicole, what do I do up here? What did I have up there? Do we multiply? Okay, that's your final answer? Okay.
It's divide.
It's divide. Okay, and why does that work? Now, so you can reason it through. If you can't reproduce this thing, you can always reason it through because there was a big sentence I wrote on the board, and I used carbon as the example. If you take an element and you express its atomic weight, it's also called atomic mass, if you express that in grams, that will be 1 mole. So if you're talking about carbon, and I ran you through just some problems in your head, I said, I got 24 grams of carbon today. How many moles? Well, what did we do? We divided it into packets of 12. And so you told me 2 moles. You said that so fast you probably didn't even really think what it was you were doing. You just knew that was the thing to do. So if you have this and you want to go to there, we divide by the formula weight. If I want to go back, then Nicole, what do I do? Multiply. And if in doubt, unit analysis will tell you if you did the right operation. Okay, then if you got moles, and we haven't done this kind of problem yet, although we talked about it. I got moles, but I'd really like to get to atoms, number of atoms. Brittany, what should I do?
Multiply by the number of atoms.
Okay, which
Which one are we doing?
okay, moles to,
Are we doing carbon?
I could do anything. I got 1 mole of anything, and how many atoms is that?
The amount of the atomic number.
Not atomic number here. I have not gave it away. I'll erase that. Okay. To go from here to here, we use the, whoops, I put formula weight, excuse me. I was thinking ahead to when we were going to do compounds in just a moment. This should be atomic weight. Atomic weight. Okay, hopefully that cleared up. So if you had it written formula weight, erase it. But now moles. I want to move on to atoms. Every time I have a mole, remember the number we memorized? How many atoms? Sarah, what should she do?
6.02 times 10 to the 23rd.
Yeah, multiply by that. Okay, because every time you have 1 mole, you got that number. Think about dozen. If I have 1 dozen, I got 12 particles, right? If I have 2 dozen, how many do I have? 2 times 12 is 24. It's just like dozen, it's just a bigger number. Okay, and if I want to come back, if for some crazy reason we happen to know how many atoms we had, then we divide by that same number. Now you can always reason it through, but this is the mechanical automatic pilot approach. So now let's go back, and we're in section 5, and this is problem 2-5.